I want to look briefly at how gates work in computers. And actually by computers I mean circuits. So here I have two inputs. These are my inputs. My input is A and my input is B. And what I'm doing in all of these diagrams is I'm assuming that my flow is going here to the right. So what's happening is this wire is coming out of A, and then I'm going to take that and AND it with this wire coming out of B. Now, well, so let me say this line right here will have A and B on it, okay? So then I'll take that and OR it with something else, and that something else is, well, here I split B. So I'm going to OR A and B with B. So what's actually on this line is A and B or B. Now that comes through here and then goes through this NOT gate. So what's coming out of here is not A and B, better get another set of parentheses there, or B. So that's kind of what this circuit does to its inputs. So what does that mean for us? Well, its inputs are either going to be a high charge or a low charge. And we'll think about that high charge as a 1 and that low charge as a 0. So these will all be either 1s or 0s. And the way the gates work is an AND gate works like our logical connective AND using true for 1s and false for 0s. Similarly, the OR gate works the same way. The OR gate works as an OR using trues for 1s and Fs for 0s. The NOT gate works like our logical NOT, our tilde, and it just switches trues and falses, 0s and 1s. So let's look at this and let's see what would happen if I fired through here 8 bits of information on each of these wires and then recorded the results. So let's just start at the left and start with this AND. So this AND is only going to be a true of 1 if both of the inputs are a 1. So I have a 0, oh, I drew that right next to where I wanted it. I have a 0 and 1 is 0. 1 and 1 is 1. The third spot is 0 and 0 is 0. 0 and 1 is 0. 1 and 0, and the fifth spot is 0. 1 and 0, 1 and 0, 0 and 1. So out of that AND gate, on this wire, I'm going to have 0, 1, 0, 0, 0, 0, 0, 0. I'm going to take that and I'm going to OR it with B, which is 1, 1, 0, 1, 0, 0, 0, 1. So this OR will be a 1 if either one of them is a 1. So in my first spot, 1 or 0 is 1. 1 or 1 is 1. 0 or 0 is 0. 1 or 0 is 1. 0 or 0 is 0. 0 or 0 is 0. 0 or 0 is 0. 1 or 0 is 1. Okay, now I'm going to take that, put it through this NOT gate, so I'm going to NOT it. So not 1 is 0, not 1 is 0, not 0 is 1, not 1 is 0, not 0 is 1, not 0 is 1, not 0 is 1, not 1 is 0. So if I shoot those two things through here, I'll get that output, 0, 0, 1, 0, 1, 1, 1, 0.